Hello, my name is Filip and I'm very happy to be able to talk to you about best practices for development and operations of Cloud Composer environments, and this way hopefully maximize the benefits of using the product. My name is Filip Knapik and I'm a product manager for Cloud Composer, part of the Google Cloud team. For those of you who are familiar with Apache Airflow, but not that familiar with Cloud Composer, what you may need to understand is that this is a fully managed Apache Airflow product with full compatibility to its open source counterpart. Therefore, any DAGs or workflows you may want to run with Apache Airflow, you can also run in Cloud Composer and this way benefit from a fully managed environment. Now, since this is a fully managed environment, there are some features that distinguish it from a self-managed Apache Airflow. And I would like to spend just a minute to call these features out so that we understand how they differ. And then we're going to dive directly into the best practices for development and operations of environments. When it comes to benefits of a Cloud Composer environment, first of all, I would call out the deployment speed. You can get started with the product very quickly and practically in 20 minutes get an environment up and running without having any prior experience with Apache Airflow. And since this is a managed environment, what you're also gaining is the fact that you don't need to manage your own patches or underlying components and upgrade them as needed. And you also don't need to look into reliability metrics and essentially worry about having your product affected by outages of underlying components. This is all taken care of as a managed product. The cost of using Cloud Composer is predictable, and I would even argue it is well optimized for use. What I mean by this is that it optimizes for total cost of ownership, and therefore the fact that you don't need to manage individual components of the platform, of the architecture, of the infrastructure, you're saving time that obviously can be accounted for also from a cost perspective. Since this is a product fully compatible with open source Apache Airflow, the code that you run in Cloud Composer is fully portable to its open source counterparts. And therefore, you can freely move your DAGs into Cloud Composer from Apache Airflow and out, obviously assuming we're talking about the same versions, without a fear of being locked into a specific platform or specific product. Enterprise customers will specifically appreciate the fact that Cloud Composer comes with multiple security features that are available out of the box. And we're going to cover some of them later on in today's presentation, but elements like private IP or shared VPC or even network perimeter are supported out of the box by the environment, and you don't need to spend time on configuring those. Last but not least, Cloud Composer as a managed product also comes with technical support. So in case there is any outage or issue that you may need to have some help with, you can always refer to Google Cloud Support asking for additional assistance. Obviously, that follows your agreements with the technical support from Google Cloud that you have in your organization. So without further ado, let me dive into development practices that hopefully will maximize the benefit and experience from using Cloud Composer. Let me start with a somewhat pessimistic but actually optimistic message, which is that every task can fail. And while it may sound not that encouraging, what I mean by this is that in fact, you can and you should account for potential failures and build some measures into your DAGs that recover from those issues. And a great example is using a built-in retry policies that can recover from issues, for instance, network outages, and therefore get your DAG properly executed, successfully completed, even if a particular task goes down because of, for instance, a network issue. So always remember about building a proper retry policies directly from the very beginning, and it shouldn't really be an afterthought. It should be a part of our regular development practices. However, for retries to work properly, it is very important to have your tasks idempotent. What I mean by this is ability to run a specific task multiple times and expecting the exact same result every time. Now imagine that you are creating some kind of an entry in the database and you insert into table using a command, and then you have to rerun the same task. By doing so, you may end up having multiple entries simply duplicated in the same database table. That's probably not the best approach, and this task may not be idempotent as such. And therefore, a better way to handle the exact same request is to, for instance, insert or replace with a specific key that is assigned to this specific transaction, and therefore, if repeated, will land in exactly the same place in the database, and worst case will simply overwrite the same entry. And this way, a particular entry that inserts the data into the database becomes idempotent and works very well with a potential retry mechanism. So always remember to use retry and think about idempotency of the tasks that you're orchestrating with it. While developing Airflow DAGs, it is very important to leave the work that needs to be implemented and executed as part of your workflow for operators and tasks. There is a temptation to put some logic, some transformations outside of the tasks and outside of operators. But the challenge with doing that is that Airflow doesn't really then have a great visibility into those activities and also can't really delegate this work to individual workers, which is not ideal from end-to-end management of your workflow logic. So the rule of thumb should be to have your DAG as a very simple and streamlined piece of code that delegates all of the work to individual tasks that are implemented using proper operators. Speaking of operators, you will also likely need, obviously, as part of the Airflow DAGs, to interact with many other products. And you may end up in a case where you realize that you have never used a particular integration before and you want to start creating your own operator or a sensor or a hook to essentially connect to those external systems. My hint on this specific scenario would be to always look into whether there is already an existing operator or integration created for that specific interface and try to use that. The community has put tremendous amount of work and effort into building operators that are available for the most common interfaces, the most common products, and also protocols, and this way enable a broad usage of Airflow with orchestration of those different products and services. So again, instead of trying to write your own operators, always try to see if you can use one of those that are already there and benefit from what the community has done. And if you need to create another one and you realize that somebody else may benefit from it, you may also consider contributing it back to the community. While creating your DAGs, you will often get into cases where to properly implement your business logic, you need to be supported by some modules that are delivered outside of your specific DAG. And typically you would rely on PyPi modules, basically Python modules that extend the capability of your DAG. And the best way to manage installation of the PyPi modules is through a built-in feature that is available in Cloud Composer. So this feature allows you to define which packages are necessary for your individual DAGs, and they are being installed in the environment as a dependency for your DAGs. And obviously it makes them available right away for your DAGs in their execution. One more hint I would like to pass in here is to avoid using a specific version if you don't have to, and leaving it blank means you're more future proof and you're not specifically limiting yourself to a version that you have created and used at this particular point in time. So again, use the specific version only if you really have to for particular reasons. There could be cases where you may want to create a DAG that consists, in fact, of a hierarchy of different DAGs or is somewhat modular. And this could be to abstract a piece of work and keep it as a contained piece of logic that basically a bigger DAG can interact with. And there is frequently a question on how to best deal with this scenario. Should I use subDAGs or some other way? And I would personally not recommend using subDAGs, and the primary reason is that there could be some operational issues with doing that, deadlocks and many other scenarios. And as such, probably one of the best ways to handle that specific case is to use DAG Run Operator instead. And this way, from a particular task of a DAG, expose, make a request to other DAGs and make them executed as part of your core DAG, as we are seeing here in this specific diagram. So again, use DAG Run Operator instead of trying to use subDAGs if necessary. So these were the high-level development practices when it comes to coding of your DAGs that I wanted to pass. But there's also a lot of hints and recommendations I would like to share when it comes to architecting your composer environments or managing them moving forward. So let me start with probably one of the most important items that I would like to call out in this space, and that is to upgrade your environments frequently. The Airflow community is putting tremendous amount of work and effort in improving the quality of the product and shipping features that the community will benefit from. Staying up to date with the Airflow release gives you access to all of those new features and bug fixes that the community has created. And the rule of thumb is to not fall behind more than 6 months from what has been announced or shared by the community, and this way not falling behind basically the benefits that those new releases bring. Now, since the upgrade process itself can be somehow heavy when it comes to effort, there is a feature in Cloud Composer that addresses this challenge a little bit. And that is the upgrade feature that allows you to upgrade an environment in place and prevents you or avoids the need for creating a new environment, moving all of your DAGs over, or for instance, even worse, losing the history of your DAG runs. So again, use the upgrade feature to keep your environment up to date and stay with the recent version of Airflow to benefit from all the features it brings. I also want to spend a moment talking about security features because this is important for multiple customers. And obviously, there's a lot of security features you can choose from, and I highly encourage you to look into those and pick the ones that are best suited for your organization and your individual needs. The first one I would like to call out is private IP. With private IP Cloud Composer environments, the nodes that are being used for compute of Cloud Composer are not assigned public IP addresses. So with that, they can't really be addressed or accessed from outside of the VPC network, and as such are protected from a networking perspective from such access. They still have access to the outside world. They can still reach out to the internet, but they simply can't be accessed from the outside. Now, when it comes to the web server of Cloud Composer and user interface for Airflow, the primary protection mechanism and security mechanism when accessing this component is authentication. So only authenticated customers and users have access to a specific Airflow user interface. However, some customers want to have one more layer of security for the web server as well, and that is a network layer. So if you want to have network level protection for your Airflow user interface, you may want to use web server access controls that, together with private IP, make your environment not accessible from the outside world unless the caller belongs to a predefined and whitelisted set of IP addresses. So this is like a firewall setting that secures access to your web server from the outside world, which you can use to configure and further tighten access to your Airflow web server. Another feature that may be used in conjunction with other components is VPC native mode, which puts your Composer environment and specifically the GK cluster that it uses into a VPC that allows for access to other components in the same VPC. Customers that want to have ultimate level of network level protection may also want to use a feature called VPC service controls. What this feature gives is ability to configure a network service perimeter, which becomes a standalone isolated network that prevents access from the outside world, but also prevents access from within the perimeter to the outside world, creating a totally separated and isolated network. And services deployed into such network perimeter are ultimately secured from network access perspective. This setting, this architecture also comes with its own challenges because, for instance, you can't easily use externally hosted PyPi packages because this network connection is not available anymore. So while it comes with additional complexities to manage, it also comes with increased security. So some organizations may choose to use this feature to further secure their Composer environments. Two more features I would like to call out for Composer are shared VPC and domain restricted sharing. With shared VPC, you can create a VPC that becomes a central hub that multiple projects connect to and exchange information with one another through that hub only. So this gives customers a central place of management for network traffic and control. And as such, if you create and deploy a Composer environment to one of those projects participating in the shared VPC setup, you gain a lot of control over the network traffic originated from that Composer environment or coming into it. So this is something that some customers may want to consider as well. And the last security feature I would like to call out is domain restricted sharing. And this feature allows customers to restrict specific domain names that need to be there in the addresses of individual accounts for access to the Composer environment. And as such, even if somebody has been granted access to your environment but does not belong to a whitelisted domain, which could be your corporate domain name, basically won't be able to access your environment without proper domain name in their email address. So this is something that customers can also choose to further secure their access to Composer environments. Another feature that might be worth considering is integration with Google Secret Manager as a way to manage secrets for your DAGs. It is very frequently the case that when managing integrations from Airflow DAGs to other systems, you need to use some keys or some passwords to connect to those external systems. And the question is, how do you best manage those secrets and keys while doing so? The recommended approach from my side would be to use Google Secret Manager as a backend for managing such secrets. This integration has been introduced in Airflow 1.10.10, so you need to use that version or newer, and has also been recently added to Cloud Composer environments. And this is something I would highly recommend for all the customers that need to use secrets, keys, passwords when integrating with external systems. This recommendation or hint is almost too obvious to mention, which is to separate production from non-production environment. And while it sounds obvious, it is important to call out that as you create your production pipelines that run your business process and business logic, you need to have a separate environment to test the newly created DAGs or changes to those DAGs separately from it. And that's particularly important because not only you need to have management separation, but you also need to have fault domain separation as well as management separation and um, performance and capacity separation. So for all those reasons, you should have at least two environments, one for production, one for other use cases. Obviously, you can end up with multiple environments for different stages of your life cycle, depending on how your organizations implement that. One more item I would like to call out in here is to also use CI/CD. So as the deployment process of DAGs requires you to place DAGs into the environment, you want to make sure that you control how this flow works. And there's a lot of different ways you can establish CI/CD pipeline that leads to a proper DAG deployment. We don't have a single solution as part of our product, but we have recommendations in our website that you may want to look into on how to do it. Again, there is not a single solution because there is not a single architecture that customers follow. But again, I highly encourage you to look into the documentation that we have that may help you establish those CI/CD pipelines for your specific use cases. And one more thing to add in this specific scenario is while you're having your separate environments for different stages, please ensure you're using the same versions of Airflow and also have the same versions of dependent PyPi modules, as otherwise the testing may not be reliable enough. Once you develop all of your DAGs, you need to ensure that they run successfully in production and deliver the right results. And to help in this specific need, we have created a monitoring dashboard that is a landing page for Cloud Composer environments. And it consists of different charts and metrics that you can think of as three different layers of an abstraction in a way. So the upper part, which I'm going to show in a second, covers statistics and data around DAG runs. The middle part covers Airflow processes and the health of individual Airflow components, and the bottom part covers the infrastructure and, for instance, metrics like CPU or memory consumption. I'm not going to go through every single chart that we're seeing here. What's really important is to learn how to read those diagrams and see the correlation between different components that may occur at the same point in time. So for instance, imagine that we're seeing that specific tasks started failing at a point in time. Then we can look into whether DAG bag size have changed. And for instance, this failure that we have just witnessed may be coming from newly created and newly deployed DAGs into our environment, which actually, if we then look into Airflow monitoring or even more so infrastructure monitoring, we can realize that, well, these new DAGs have caused the CPU of the infrastructure to be maxed out, and therefore lack of resources is probably the reason for the failure of the tasks. So correlating those different charts and metrics together may help you understand the story behind particular issues or outages that you may look into. Obviously, I'm not saying that the monitoring dashboard is the only way of troubleshooting, but it can be a helpful tool in trying to understand what might have gone wrong in some of the DAG executions. One more recommendation I would like to pass at this point is to also establish your own monitoring alerts so that whenever something goes wrong, for instance, you have an unprecedented error ratio for your DAG runs, that you're notified about those cases because nobody actually wants to be looking into those dashboards all the time. We're not currently shipping any standard set of alerts because there's not a single solution on how to do it and how to get notified. But since all of the metrics that you're seeing in this dashboard are available in the stack driver, you can create alerts to get notified about particular challenges. And I highly encourage you to look into that feature and use it as well. Obviously, what's also very important when it comes to troubleshooting your environments is looking into the logs. Monitoring is obviously not everything. What's important and where Composer also helps is by showing you all of the logs from different components of the infrastructure in a single place. So for instance, as you can see right now, I'm currently highlighting Airflow scheduler logs, and therefore if I want to look into specific issues that scheduler may have faced or may have thrown as errors, I can easily see it in a single place coming from different components of the infrastructure. So that's a handy tool when it comes to troubleshooting different issues in different places of the Composer and Airflow environment. What is also very important when it comes to ensuring that your DAGs run successfully is to scale your environment accordingly. And there are three components in the infrastructure that you can scale independently. You can scale the Airflow compute layer, which is the GKE cluster, and add more nodes as you need, and therefore get more capacity for processing your DAGs, for running your workers, for running your tasks as part of your DAGs. You can also increase the size, basically scale up an Airflow database. If you have DAGs that are particularly effort intensive at a database layer, you may choose a larger database instance and this way have additional capacity at that layer of the infrastructure. And the last component you may want to consider scaling up is the Airflow web server. So specifically, if you have a lot of different DAGs that the web server has to process, or there's a lot of different users that want to interact with it, you may want to create a slightly larger web server to have the Airflow UI with more capacity as part of your workload. However, what is very important as well when it comes to scaling of the Airflow web server is the next feature I want to introduce, and that is enable DAG serialization. So this is a feature that is currently not a default of the Airflow environment or a Composer environment. It may become one at some point, but today in a default approach to implementation of Airflow and Composer, the web server is continuously processing your DAGs, trying to understand what's inside and how to visualize them and what these DAGs are. If you enable DAG serialization, however, the Airflow scheduler is taking one more step, one more responsibility, and that is to serialize the DAGs and save the outcome of that serialization into the database. From that point on, the Airflow web server is actually reading the outcome of that serialization instead of going through a continuous endless loop trying to run your code as part of the web server. And this is a significant reduction of the work that the web server has to perform. And also, as such, it is significantly reducing the needs for capacity of the web server and the risk of a potential instability of the web server because it no longer needs to run any somewhat untrusted code as part of the web server. So this is a feature I would highly recommend to reduce the load of the web server and increase the stability of the entire system. So with that, let me very quickly recap all the items that we have gone through very quickly today as a way to hopefully help you manage and implement your DAGs in a way that give you the biggest benefits from using the product. So again, assume that failures will happen and are likely to happen even for the best and the most reliable endpoints. And use built-in retry and error handling mechanism in Airflow, and therefore make your DAG runs not vulnerable to those issues and successful practically all of the time. To support that, also make your tasks idempotent so that they can be safely retried without unexpected consequences as part of your DAG executions. Leave the work to the operators. Don't try to put the code in between the tasks, between the operators, so that Airflow can properly manage the distribution of the work and errors that may arise from it. Use existing Airflow integrations, all the operators, hooks, and sensors that the community has created. It's a very long and comprehensive list and very helpful in getting you started with most of the systems around. Take time to manage the Python modules. Ideally, without specifying the versions, use the ones that are available already. Upgrade your environment as frequently as you can, and ideally, don't exceed the window of 6 months without an upgrade, because this can render your environment as outdated and lacking the recent bug fixes and improvements. Use built-in enterprise security features. Since this is a long list of potential features, you may need to choose the ones that fit your organization and your security policies and regulations. But look into those, please, and choose ones accordingly. For managing of your secrets and keys with other systems, highly recommend to use Secret Manager as a way to manage basically all of those components that you need to have for your integrations. Use separate prod and non-prod environments, use CI/CD, and ensure you're running the same versions in all the environments with the same packages. Use Composer's built-in monitoring dashboard and logs, and if possible, also establish and set up your own alerts so that you get notified on any potential outages and issues that you may encounter. Scale your environment accordingly, remembering that these are three different elements that you can scale independently: the compute layer, the database layer, and the web server. And then use the DAG serialization to reduce the load of the web server and increase the stability of the web server as a component of the overall platform. With that, I wanted to thank you very much for attention. I hope some of those hints were useful, and I'm looking forward to see you using Cloud Composer and contributing also to Apache Airflow community. Thank you very much.